The following program is presented by the Metropolitan Library Service Agency.
Hello, welcome to All About Kids, a program focusing on the interests of children and young people and some of the issues affecting them. Our guest today, Janice VanCleave, is a science teacher and the author of numerous books. Today she'll be talking about her new book, 200 Gooey, Slippery, Slimy, Weird, and Fun Experiments. She'll also be discussing the importance of science education for youngsters. Later on in the program, Janice will be demonstrating some of those gooey and weird experiments here in the studio. Janice, it's obvious from the titles of your books that you are a person who has an enormous amount of experience working with children. After years of showing kids books that say 1,000 productive science projects and look tedious and boring, you've obviously struck exactly the right note to get kids interested in science projects, because nothing is more intriguing than slime and goop. How did you get into this whole business of writing such interesting kinds of things for kids?
Well, 26 years of teaching, for one thing, gave me the background, and I don't know that I ever taught the same thing every year. But I was teaching in Arkansas, and I actually was teaching high school and doing enrichment classes for elementary children after school, and a publisher in New York City saw the advertisement. I couldn't believe it, in this little tiny catalog, and wrote me a letter and said, "Would you like to write a children's experiment book?" Too fun. After I did about 3 backflips, well, yay! So, that's how it all started. It sounds like a fairy tale, but
it's based on your practical experience and knowing that kids really need to get in there and muck around to get the concepts and the theories.
Children want to touch, feel, taste, hear. Well, we do too, adults want the same thing. We want to be involved is the key word. They want to be part of it, and that's what this book does for them.
Well, I think one of the things as a public librarian, not only do we have constant requests from children and their parents and other teachers about books that help kids get excited about science, but children's librarians do a lot of programming in libraries, and your books are standards with us and also child care providers, because you have some very, very basic, fun experience that explore concepts that even preschool children can understand.
Well, our selling market for the books that I write are kindergarten through high school. Reading level is 8-year-olds through 13-year-olds. That's the reading level. But the children that are involved in the books, and parents and teachers that buy the books, pre-K, like I say, right on up through kindergarten. And the reason that we find that they're very popular, they can do the experiments. The materials are things that they can find around the house. There's paper clips, etc. And not only do I write science books, I have written this one, which is called Geography for Every Kid. And geography is more than just finding out where a state capital is or finding something on a map. Geography actually is a science. It's a science of where it happens. And so geography can be fun, and I have lots of fun experiments in this book also.
So obviously your books cross disciplines and can really be integrated into a whole language curriculum to
That's correct.
help children understand the connections between different kinds of sciences. You obviously have a passion for helping children become involved in science, and I think those of us who work with children are concerned that math and science aren't always at the top of the list for a lot of kids and for a lot of parents. It's kind of a scary topic if we haven't done well in school. Did you find as a classroom teacher that there was this fear of science or even geography?
Well, and a lot of times it has come from parents, and I always advise parents not to give the child, say, an excuse for doing poorly in science or not liking science or math particularly. If a child comes to my class and says, my father didn't do well in math, it's almost kind of like, well, Dad didn't, so I don't have to either. So parents need to be very careful about giving this negative view, because the children love and respect their parents. And whatever the parent respects and loves, the child is going to fall right in line. So even if the father maybe or the mother didn't do well in science or in math, they don't have to tell fibs about it, so to speak, but they don't have to emphasize it either.
Well, again, your books, though, don't emphasize the seriousness of it. They talk about how much fun it is, and that can really help to dispel a lot of stereotypes or overcome some real bad learning or teaching situations that adults have been through.
I think that parents and teachers alike will find the experiments are things that they see around them. When they flip through the book, they'll see plants, you know, how they lean towards the sun, and if you the actual movement is towards the window where the sun is. And you can just use these experiments to key into things around you.
Well, I think it's hard to show the illustrations from the book, but this is a wonderful enlarged sample, so it gives the viewers an idea of the format, of how concisely you've written the experiences, and just the fun view of it. So it, again, books on display like this are hard to pass up, and I think when you go into a classroom or to make a presentation, the way you're dressed, we talked a little bit about that. You have a whole wardrobe of dazzling.
Yes. Well, I have a designer, Sue Dunham. She's a designer in Texas, and she makes my costumes, so to speak. This one is glitzy, but many of them are made out of denim, and she has taken pictures from the books and actually drawn the pictures on so that you see, like the little paper that you just held up, you would see this on my, and it's always a vest. And I have a series called Science Project Books, and in this series there's a caricature of me, and this lady is always in her little vest, like if it's a volcano book, you've got volcanoes exploding or magnets, etc., and it's really great
And
fun.
there's nothing that children enjoy more than looking for something like that in the pictures, that continuing thing.
Yes.
So again, everything designed to make learning fun. What kind of reaction do you get from other educators? Do they find your books in their classroom
Yes.
really revitalizing their own teaching of science?
I find teachers and librarians alike, the instructions are simple and the materials easily obtained. And then there's always a result, so they know if they've done it correctly. But it's the explanations. The explanations are very simple, not that, and I'm writing to children. So I'm writing so that the child is understanding the scientific principle, and it's in terms that they can understand. Elementary teachers particularly enjoy the books because they don't have to read the explanation and then try to get it down, say, on the children's level. It's there. It's ready to use. It's instant science.
So rather than redesigning, I think we often try to make things more complicated than they are.
Yes.
And this works out very well. Well, obviously you've got a long line of books, and you're continually looking for new topics. After geography, what?
I am presently writing. I'm working on 2 books, as a matter of fact. I'm working on one that'll be called, it's in reference to human body. We haven't quite decided on a title, but it will be about the human body. And then the second book will be a project book about weather. And then after that, we're way ahead of the game. My publisher, which is John Wiley Publishing in New York City, the third book that's coming up will be a fact book, a fun fact, so that teachers would be able to use this and pull out interesting ideas, but also in the book there's going to be a question section so that they would actually have questions about all of the facts that are in the book. Instant use for educators, for sure.
Well, and again, kids love those odd facts, and probably some of those things would tie back into your earlier
Oh,
books.
yeah.
So again, integrating all those kinds of concepts. Well, we've been talking about how much fun it is to do science projects, and I think we should
You
be
ready
like
to
those
do some?
kids and get in there and dig around. And I'd love to have you show us some of your samples
would
and
love to do
explain
that.
some of them. I am dying to get into this group, Janice, and we really want look at some of these experiments. But first of all, I think the viewers, especially the young people who might be watching this with their parents or teachers, would be real interested to know that you have a science club, Science for Every Kid. And there is a newsletter which comes out on a regular basis.
It comes out quarterly, and it is free. They do not have to buy anything. They never have to buy a book. Of course, we would certainly like for them to, but they do not have to. It is free, and all we need is a name and an address. We're looking for a mailing list for children, and we'll mail this directly to their home. And they will get each one of them that come out. And what's on it? Experiments that come out of my book, and also puzzles and just little science tidbits.
Well, I love it. And children write in and ask you about the projects that they've been involved in, and that's fun. A crossword puzzle at the end and some of the interesting tips. And at the end of the program, we'll leave the address that
and all we need is, and we're looking for numbers. If teachers want to get the names and addresses of their children in their class, then we'll mail to these kids.
And this is all coming from your publisher,
That's
John
correct.
Wiley. That's fantastic
correct.
that a publisher is that interested in making that link
I'm
into
very pleased.
the community. So if people are out there watching, they might want to take a piece of paper and a pencil right now while we are getting into this.
And you know, you are so correct. You say, I want to get my hands in it. Well, the kids want to get their hands in it too. I put this in a book. Obviously, if you have a book that's called 200 Slippery, Slimy, Weird, Gooey, Food, and Fun Experiments, you have to have something that looks like this in the book. This is called The Glob, and it's very creepy and very fun.
There's nothing. What about the parents who are saying, oh, what's going to happen if they start making the glob in the kitchen?
Yes, well, kitchen will be a fun time and a fun place to make it. It's that living room that gives them a little more concern. This is water soluble.
It's nothing on my hands.
Right.
It feels good. It feels
and it's
wonderful.
made out of borax, like 20-multine borax, and glue like Elmer's school glue. And it does stick to things. It does stick to my clothes. It sticks to but the nice thing is if I take some soapy water and put a little bit of vinegar in it, Mr. Glob here just dissolves right away. So he's fun. Oh, and the color. Some of the children, they ask me, do I use the colored glue that they buy? And no, I don't, because I want to make my own colors. So I use food coloring to make the glob. And he is slimy. Oh, let me show you something. When you pull him up and you pull him quickly, he breaks. But if you just leave him alone like we're doing here, he just slimes around. And so this is Mr. Glob. But there are lots of other fun experiments in the book. For example, let me show you this that's about center of gravity. This is nothing more than a piece of a folder, a file folder that I've cut and experimented with. And I've discovered through experimenting that if I put paper clips on its wings and pull them close to the end, then if I take a pencil, particularly one with a flat eraser, this will stand right on the tip. So what we've done is made the center of gravity, which in the book it describes the center of gravity as the balancing point. So that's its definition, and this is definitely something that the kids love to do. But they can extend this. As teachers, they can make something that's even a little bigger.
I watched our text getting a little bit nervous when you started setting this up.
I know. This looks like, oh, sure, lady. But if you have weights on the ends, just like the weights on the end of the paper, we cause the center of gravity, which again is the balancing point, to be on the tip of its nose, and voila, we can make something as heavy as this piece of wood. Now, teachers don't have to make something this elaborate. They can experiment with cardboard, like the side of a cardboard box, and you notice that I have the wings extended with the weights on the end. And instead of paper clips, I've put paper cups, and inside the paper cups are washers that weight down the wings.
But this is exactly the kind of project I can see a family doing at home with a young student and bringing it in for the science fair, and the pride of that student doing it. Before you go on to the next one, I want to see
You want to see if you
I
can
do
do
this. I haven't done a science experiment since high school chemistry. It works.
It works. It works. And it is so stable that usually I can just give it a little twirl like this, and it twirls around like a carousel. Now see, it works for you, it
shall-
works for everybody.
I shall give up literacy and go into science.
Go into science. Another thing that is really fun, this is a report folder. You can buy them like at the store. They'll come in a package, and you'll have red ones, green ones, yellow ones, blue ones. And you can read on here that it says Janice VanCleave's Biology for Kids, and you see red and you see black print. But if I kind of put my fingers underneath this and I pull the red folder up, you see the colors are very, very bright. We have yellows and pinks and orange, but when we put this back down again, it appears that it's magically disappearing.
And what's the theory behind that?
Well, first of all, science is not magic, but because of the waves of light, they're so close. This is not pure red. It has some orange and some yellow in it. And you have these waves coming towards your eye. And then the pink and the yellows, they're coming, and they're so close to the same shape of the waves that your eye doesn't separate them. It's kind of like the waves blend together. And then with a class, you can use this to introduce waves of light, if that's what you're speaking about. Or you can talk about animals that are camouflaged. If a rabbit that's kind of gray is sitting on white snow, then he's not as visible to his predators, and so he's a little safer. And so this is an experiment that can be extended to many different things. Now this one is a sound experiment. Now teachers have to have a good day to do this one, and you'll see why in a second. What I have is a cup. It has 2 holes in it, and I've put a string through it. I have a toothpick, and this toothpick is preventing the string from cutting through the cup, so that if I pull on the string like this, the toothpick is keeping the string from cutting. Now on the other end, I have a sponge, and since the sponge is a little wet, or it needs to be a little wet, I'm going to pour a little water in this lid so that I can moisten, not drippy wet, but just moisten the sponge. And holding the cup with this moist sponge, I'm going to wrap it around the string. And always, I tease the kids when I do this. If they've not seen it before, I tell them, now this is a special sound, and you have to be very quiet. And so they're all, and I've even had them to hold their ears up or do this so that they can capture, and they've learned, you see, they've learned that they can capture the sound by holding their hand to their ears. So here's our sound. Obviously not a quiet sound, and they're always, shocked when they hear it.
But
and
they love it.
They love it. I call it a clucking chicken. And what I'm doing is wrapping the moist sponge, and I'm jerking. And the sponge is going down the string, causing the string to vibrate. Well, in the book, this is in the physics book that I've written, and physics is great fun. Sometimes people say physics, and just the word scares them off. But physics is about sound and electricity and magnets. But with this one, you're pulling the sponge down and you're causing the string to vibrate. And I tell the kids, vibrate means to go back and forth. So the string is vibrating, causes the cup to vibrate, but the cup also acts like a megaphone that causes the sound to be projected outward. So this is a great, fun experiment.
Again, so simple. I'm absolutely astounded that
It's
everything
very
is
simple,
so
yes. In doing the science experiments, particularly with the glob and things like this, the fun thing about it is that, one, the procedures are easy, and the materials are easily obtained. Again, I point out that this is like made out of Elmer's glue and borax.
And they're all things that are non-toxic.
And they're
that
things,
you can
yes.
be real.
And I do want to
Please
point
let
out that
children
this
use.
is non-toxic, and we'll clean this jar off so we can see what we've been hiding under here all of this very time, because you see how it sticks. And this is an experiment in itself, that it doesn't seem to stick to this glass, and yet it sticks wonderfully well to paper. You have to be careful and not get it on paper. I can also point out, since we're cleaning Mr. Glob off of here, that Mr. Glob lives in a Ziploc bag. When we're not allowing him to slime around, what I do is I put him in his bag, and it keeps him from dehydrating. So, you know, that's a word, a science word that the children can learn, which means that it dries out if it dehydrates. You have to also be very, very careful and zip this bag. I have made a couple of mistakes in that I didn't get the bag zipped, and Mr. Glob would slime right out, so you have to be careful with that. Also, if he gets very warm, he grows a beard, which is mold, obviously. And so I keep the bag in the refrigerator when I'm not allowing Mr. Glob to slime around. And I'll get this off of my hands, put Mr. Glob back in his house. And then in this jar, we have what looks like rice, and the looking is right, it is rice. But when I do this, I tell the kids, let's pretend that this is not rice. Let's pretend that this is a section of the earth, and this is sand. And 20,000 years ago, we set up a VCR camera. Surprisingly, I do this, they never even blink an eye. VCR cameras are so common with the children that they don't think that they haven't been around, 20,000 years ago. So we set up a VCR camera on this section of the earth. Now, in the summertime, the sand grains and all of the molecules in the earth, they tend to expand because they get warm. And in the wintertime, they contract because they get cold. And so over 20,000 years, you have the earth going, and they're doing all of these exercises. And some places there are fault lines, and you can get into that, and so there's jiggling and shaking, and you have jiggling and shaking with earthquakes and expanding and contracting. And what happens is something strange happens to the earth in some places. We're going to look at the camera now, we're going to speed it up, and we're pretending that we're looking at the VCR camera, and we're speeding it up now, and here's what you're going to see happening. And up comes large. I saw your eyes.
Surprise.
Yes, you see, I didn't show you this ahead of time so that I would get this, and that's exactly what the children do. You get this surprise in their eyes. When I use this in the classroom, I'll have this sitting on my desk just like this, and they're going, what is that? What you got to go out, a jar of rice for? And of course, if you do things in the class all the time, they begin to know that there's going to be something good that's going to happen here.
Anticipation.
That's right. That's correct. Now, with students in the class, this is for a demonstration. This is glass, and it's large, and when I shake it many times, it makes my own arms sore because it's heavy. But with kids, you can get a smaller container, and I've recently seen a peanut butter jar that is, fairly large around, and its lid is very large also, and about so tall. And you fill that half full with rice, but instead of putting a tennis ball in it like this one is, you would put in it like a small ball, like a little jack's ball, and then the children could do it themselves. And that's the whole thing. You want hands-on for the children. They don't want to always see me do it. They want to do it themselves.
Again, that's how they learn, that's how they get excited about the whole.
If they're involved, and it is involvement, and that's the problem, I think, with the education of many of the children. When they're young, they're very bright-eyed, and they're excited about science, and they want to use magnets, and they want to do this. And as they go through our educational system, teachers are under a certain amount of pressure to teach certain curriculum, and sometimes time is difficult. Money is difficult to obtain, to buy fancy supplies. I think that I am helping the teachers meet that need in that they don't have to buy things that are expensive. Rice is very inexpensive, and they can collect a jar, and so that the kids can
probably from the school lunchroom.
Exactly. Oh,
how do you counteract, or do you ever get criticism from parents who say, well, children expect all teachers to be magicians or actors, or how can you keep order in the classroom when children expect everything to be a show?
Well, children do expect it to be a show, and unfortunately teachers are having to become more like actors and actresses because you're competing with the media that is very glitzy and very polished. And so when we do things in the classroom that's not really bright and shiny and exciting, well, we have to do that. We are going to have to train ourselves to be more showy. And as far as the discipline, I didn't find that to be a problem. I haven't taught actually as a hired teacher for 3 years. I now go around and do presentations to groups. I had 700 children in a cafeteria. And that's a lot of kids to entertain at one time. And they were so excited about doing the experiments, like this little paper thing. So I find that if they're involved, they're keyed in on what I'm saying. If they're bored, then they're going to be more likely to be in things that, you know, their own acts. They're going to use their own ideas to entertain themselves.
And again, some of our concern as adults that children have too much fun in school may be sort of an envy that we didn't have some of these interesting things when we were going to school.
Well, and I hope that teachers and administrators acknowledge that there can be good noise. There can be constructive noise. If a classroom is just always very quiet, that doesn't necessarily indicate that they are learning. There can be constructive noise, and we can tell the difference. Teachers and educators, they can tell the difference between, you know, unruly, just, you know, the kids are wild day, or they're excited. There's a big difference.
And when children have that opportunity to react a little bit to things, then they tend to be more able to concentrate when it's necessary. I think we have time for one more quick experiment, and I'm looking at those bottles.
This?
Yes.
You've seen this? All right. Now, children make these by buying connectors, but I can show them how to do this without having to buy the connector. They call this a tornado in a bottle. And I personally think that mine is a better tornado, of course, because it's quite big. And this shape, this funnel shape, is called a vortex. And how you make this is you have two bottles, one which I have dropped on the floor, but we'll just talk about it. You have a bottle here with, it's half filled with water. And you can make this quite easily with a washer. This is a 3/8 inch, and it's called a flat or a cut washer. It wonderfully fits on top of this bottle. Now, I left this white ring on, this little plastic ring, because when you snap the lid off, this ring stays on. And you take that off so that when you put the bottles together with duct tape, then they're going to stay connected. The second bottle is totally empty, nothing on the top, and it sets right on the top of this. And as this example here, you tape it together, and again, you have what the kids called a tornado bottle.
Janice, you excited me. I'm going to go home and try some of these things in my kitchen tonight, and I know that there are teachers and children and parents and librarians, child care providers out there who are going to be racing off to buy your book, and we'll look forward to more of the exciting things coming from you. Thank you very much for being all about kids today.
Well, and I want the kids to have fun and do some hands-on exciting
and then write the reports afterwards.
That's right. Yes, exactly. True.
Thank you, Janice.
Thank you.
Janice VanCleave truly can make science fun. Thank you, Janice, for being a guest on our program today, and thanks to all of you for watching All About Kids. Please tune in again.
This has been a presentation of Hennepin County Library in conjunction with the Twin Cities Metropolitan Library Service Agency. We thank you for watching, and we hope you visit your public library often.